Let's take a look at some more examples here. On the first one, in this first table, or mapping, depending how you look at it, notice every x value, every domain only has one y value associated with it. So that is a function. How about the next one? Notice we got a little problem here with 0 and with 2, because 0 has 2 corresponding values that go with it. So this one is not a function. We're spending a lot of time on this because functions are a basic part of math that we have to start with. Usually, all the rules are implied to be functions. So if it's not a function, our rules don't apply. So that's why it's important for us to understand this. Now let's take a look at a couple of extreme values. Here we have an extreme value. Notice I only have one value of my range. But notice it's predictable. No matter what number I pick for x, I know my answer is 7. So this is a function. Or just the opposite. If I pick 7, I don't know what answer I should predict, so that's not a function. Those are two extreme values you'll see once in a while, and they can be kind of confusing. So if it always goes to the same number, it can be a function. It's just if it starts with 1 and it goes to a multiple, then it's not a function. So let's write that down. So to describe what it needs to be a function is we predict one answer based on our input. Sometimes it'll follow a rule. Sometimes it's not a rule, but it's still only one solution. Okay, so the whole thing is there's one predictable, whether we can predict it or not, answer for each input. Can't spell today, input.